We put a lot of trust in data and tests to give us the right answers pretty much every single day. But what happens when they get it wrong? So today, we're going to dive into the really fascinating and, frankly, critical world of statistical errors. We're talking type 1 and type 2, and why getting a handle on them is so important for everything from medicine to, well, just about any big discovery. Okay, so picture this. You go for a medical test, and the result comes back negative. You're healthy. Phew, it's this huge wave of relief, right? But there's that little voice in the back of your head, isn't there? It's asking one simple but powerful question. What if the test is wrong? And that question right there is our way into this entire topic. Because here's the thing. In the world of statistics and testing, there is always a chance for error. No test is ever perfect. And that means the results can, and sometimes do, lie to us. So let's break this down. Anytime we run a test, there are really 4 possible things that can happen. 2 of them are great. They're exactly what you want. We get the right answer. But the other 2, well, that's where things get tricky. These are the 2 very different and sometimes very dangerous ways that we can be wrong. Now, before we can really dig into these errors, we have to talk about the starting point of any statistical test. This is kind of the foundation that everything else is built on. So this starting point has a name. It's called the null hypothesis. And it's actually a pretty simple idea. It's just the default assumption. It's the status quo. It's what we believe to be true unless we find overwhelming evidence that it's not. The burden of proof is really high. So going back to our medical test example, the null hypothesis isn't that you're sick. It's that the patient is healthy. We assume health until that test gives us some seriously strong proof otherwise. Okay, so now that we've got our baseline, our null hypothesis, we can bring out the 2 main characters in this whole story, type 1 and type 2 errors. A type 1 error is what happens when we reject that null hypothesis, even though, oops, it was actually true. This is what's commonly known as a false positive. On the flip side, you have a type 2 error. That's when we accept the null hypothesis when, in reality, it was false. We call that one a false negative. Let's make this real again with our medical scenario, because this is where it really clicks. A type 1 error, that's the false positive, means telling a perfectly healthy person that they have a disease. A type 2 error, the false negative, is telling someone who is actually sick that they're totally fine. Yeah, you can see right away how both of those mistakes are a really big deal. So how in the world do you keep all this straight? Well, the best way, for me at least, is to actually visualize it. We can map out these 4 possible outcomes in a super simple grid. Think of it like a showdown between 2 things. On one side, you've got the decision that our test makes. And on the other side, you've got what's actually true in reality. And where those 2 things meet? Well, that's where we find our 4 potential outcomes. All right, let's walk through this. Take a look at the top row. In reality, the patient is healthy. If our test agrees and says they're healthy, great, correct decision. But if our test rejects that idea and says they're sick, boom, that's a type 1 error, a false positive. Now let's look at the bottom row. Here, the reality is the patient is actually sick. If our test misses it and says they're healthy, that's our type 2 error, the false negative. But if it correctly spots the sickness, hey, we're right again. And the really important thing to get here is that these aren't just some boring statistical terms. They represent a fundamental trade-off that has very, very real consequences. This quote just nails it. A false positive, our type 1 error, is basically a false alarm. It causes a ton of unnecessary stress, anxiety, maybe more invasive tests. A false negative, our type 2 error, that's a missed danger. The problem is there, but we failed to see it, and that could let it get much, much worse. I mean, think about it. We all just lived through a massive real-world example of this. During the COVID-19 pandemic, a false positive test meant someone had to isolate for no reason, maybe miss work or school. But a false negative, you could argue that was so much worse. It meant an infected person might go out into the world spreading the virus, thinking they were totally in the clear. Which really leaves us with a tough question to think about. When you're dealing with something that's not only deadly, but also highly contagious, which error is the bigger threat? Is it the false alarm that causes individual stress? Or is it the missed danger that could threaten an entire community? It's an incredibly high-stakes balancing act that scientists and policymakers have to wrestle with every single day.